Hey there, Boots Owen here. This is the Samsung Optimal Dry 8 kg machine. It's a heat pump tumble dryer, and I've done a few tests in it now. Tests, I say loads. I should just call them loads. I've done 2 or 3 loads in it already, and I'm happy that it works. But I think that the filter down here is quite blocked. Let's have a look. Not the filter, but the I need to clean this filter as well after the last load. Do that. This thing down here, the evaporator, or the... There it is. It's kind of hard to snap that on this machine. I think in here is a bit crusty. You can see it's not blocked, but it's not clean either. It could use a bit of a clean somehow. It's not too bad. Let's put this cover back in. So I'm not sure how much energy it uses, is really all we're talking about here. And I want to measure that. I want to measure how much energy this machine uses. So up on top, I better clean this first while we're here. So it's got a double screen. There's very little lint in this. Oh, there's a bit. Some guides say wash them under the tap. I've never done that. Never ever. This is a double screen. I think it really doesn't want fluff or anything getting into that evaporator or radiator, or it's a condenser where the water condenses out, of course, as well. So let's fold that up, put that in there. Now this has a little crack in the plastic here, and I should probably mend that. I've mended these before. They're quite easy to mend. It'll be in my other videos, or there'll be a link to it up in the top corner as we speak. Right, put that in there, ready to go. Close that door. Now it's not a real world test because this machine has just done a load, so it's already hot, warm. All of the components are warm, so this should be a biased one. I've taken a reading from my old-timey meter. That's what I reckon it to be. So we'll fire it up, and it's on. There we go. I've turned off the sound on it. I've got child lock on, so to get it to... Oh no, I think it'll actually just go. Child lock is on. Sound is off, and it's on the middle drying setting for cotton on the optimal dry, so it'll sense what it's doing. Typically with these loads, it doesn't want to start because of that child lock, so better turn that off. There we go. Put it back on. There's little fingers around at the moment. You gonna go on? There we go. Typically with the loads I've been doing, cotton straight as it comes. It starts at 245, then after 10-15 minutes it drops down by about an hour, and then it completes it. That's the squeaking noise, is the pump on the back, and that's actually nearly full, so I should empty this drawer once that pump stops. The time drops straight off, so it's obviously doing its sensing thing, but giving you a pessimistic start time. I wonder how much energy it uses. You can see that wheel is barely moving, you know? If this was an element dryer with a heating element, that thing would spin around and you'd see it moving. This machine says it uses between 750 and 850 watts, depending on the voltage. I don't think that's continuous, because I don't think the heat pump runs continuous in it. I don't know. We'll see how it works out. So it's been on about 10 minutes and it's jumped down already, probably because it's warm. I realized, I came to look at it and thought that's not spinning very fast, and I realized that it won't spin unless it's vertical. The bearings and that little disc there, the thing won't spin unless it's vertical, so it's just resting on itself there. But I don't know, it hasn't moved much in 10 minutes, but that's because I probably didn't have the meter set up right. We'll have to wait and see what happens there. So this will be test number 1, I guess. We'll compare a few numbers. So it's been running there for a while quite comfortably, and then it jumped from about 30 minutes down to 8. So it must think it's nearly there, and it is quite hot, and I guess that's part of it starting hot. Let's try and see what the meter says. So it's gone up from 7.6, which is about there. So it's used about half of a kilowatt hour, which is very little really. Half of a kilowatt hour. Now it might have used a little bit more, but that's about 0.4. I'm underestimating there. It's about 0.4 is what it's used so far. So if it can dry a load of laundry at 0.4 of a kilowatt hour because it's doing it back to back with a previous load, then the reality is that you'll build up a succession of, you know, you'll build up a bit of heat and you can keep rocking with it. And that's kind of neat. So we'll see if it actually does 7, because in the past it's jumped from 1 or 2 up to 10 because it keeps cycling back and forth. But looking at how the stuff is behaving in there, it seems to be doing okay. So here it is now, it's nearly finished. It's still tumbling, but it's gone onto the fan cycle. Because they're a closed loop, they don't blow the fan for 12 minutes like a normal dryer does to cool down. I don't think they care or something. Is it going to keep going or will it stop? I can hear it pumping in the background. Stop pumping. Or will it jump from 1 up to 10 again? It looks pretty dry to me. It looked dry a few minutes ago as well. Once this is done, we'll check the meter. So I would say it's been drying for perhaps an hour, maybe a bit longer. There's 0, it's done. I presume I can open it now. Yeah, there we go. So how is it? Well, it's warm and steamy. A little bit of steam, not really. It's quite dry, and it's as dry as you'd get it in any machine, and I'm quite pleased with that. So let's check this meter then. So it's between 3 and 4 over here. Where's my piece of paper gone? So it's 7604.3 point, what would we call that? I would call that 0.24. So that's roughly half of a kilowatt hour. Now if you imagine a regular tumble dryer with an element running for 1 hour, it'll burn roughly 2.5 to 3 kilowatt hours of electricity in an hour, because they're a 2.5 or 3 kilowatt machine. This is using half of a kilowatt hour for one load. That is quite efficient. So what I would like to do ultimately is compare it to gas, but it's difficult to compare it to gas because of prices and different prices for different people. So let's say at the most here it would have used 1 kilowatt hour and gas would use 3 kilowatt hours. Well, I don't know what I'm paying for gas now, about 10 or 12p, so that would be 36p, and 1 kilowatt of electricity. It's going to be much of a muchness at the moment. I guess I could be paying more or less for electricity depending on what tariff I'm on. I'll need to check that, but you can make an informed decision for you. Between 0.5 and 1 kilowatt hour of electricity though is pretty slim. So that's the first test on this Samsung machine. I'll do another test from cold another day when I have a little bit more laundry. The other detail about this machine compared to a vented dryer, gas or electric, is that with a vented dryer it takes the heat and the damp heat and throws it out of your house outside. Whereas with this one, it's completely contained within itself. So now that it's finished, it's a pretty good radiator, but for how long of course as well, until it cools down, and that depends on the temperature of your room. Right, so there. Questions or comments, leave them below. Subscribe to the channel, it's a big help I believe, and give us a like, that'd be super. Thanks for watching, see you later.